All right. So I'm glad you came back. You didn't go, hey, you know what? Had enough of this struct stuff and left me. Nope, you came back. And so we're going to work through this next section, which is going to go pretty fast. And the reason being is it's a lot of things you've kind of already done in the past. Now it's just mixing some structs in. Again, structs are structures. And because of that, there doesn't need to be a whole lot of conversation, maybe just a little bit of guidance. And if you're having problems with it, just reach out to me and we can get together, or I can shoot you some emails explaining things. But like I said, this next part just doesn't need to take a whole lot of time. And I don't want to take your time when this is pretty self-explanatory. Again, things you've already kind of been doing, right? So a nested struct is nothing more than a structure within a structure. So if you think about it, it's like putting another type of variable or member into a structure. So with that being said, here we've got this personal. And remember, before until we start using classes and other things like header files and stuff, you always have to put things in order in your file. So if you're going to use this struct in code, you got to put that struct before you use it. So in fact, this personal info is being used in this struct. And this is what we're talking about. This is that embedded or that nested structure, right? So with that being said, what we have here is this struct, which we first defined, is now going to be a member variable of this struct. This is where we start getting really into the power of programming, especially object-oriented programming. You're going to see this again when we start talking about classes and class objects, that kind of stuff. But for this, here you are seeing the struct being used as a struct. Beyond that, beyond the fact that we can do this, it's all straight up the same as anything else. It's another member as part of a member, as part to me as a part of a struct. So a struct, that's a member of another struct. And you can keep doing this, right? We could have had another struct that was defined up here, and oh, let me get my pen. We could have had another struct defined up here that could have been a part of this struct, and then this part of this struct, and so forth and so on. Now, I will tell you, you want to be careful with how far you nest. The more nesting you do, the harder it is to read the code and understand where things are going. So one way to really make sure that doesn't get too much of a problem is make sure the name of your struct is something very sufficient, something that really tells other people that might be reading your code what this is. Like, we know what a student is. Personal info, we kind of know what that is, maybe not fully in context, but then when we see it in the struct student, we go, oh, this is the this is the person's info that's about the student. And why might we do that? Well, what if we wanted to have a struct called parent? Now we have a struct named parent that can also make use of personal info. And there you go, another pillar of uh, object-oriented programming, code reuse. And we'll talk about that more down the road. All right. So how do you get to a struct that's in a struct? Very much like you would actually probably have thought. You're going to first have to, so here we have that student S. We're going to have to use that dot indicator to get to its member variables. One of them being the p data, which is another struct. And so to get to that struct's member data, we need to use the dot operator again. And now we can get to that struct's um, name variable, member variable. So it is just like that. And it would continue down the process. If we had another struct within that personal data, then we would hit dot and another that the name of that struct, dot in that member. So keep adding dots. When it comes to passing structures as into functions, it really does it is very similar to passing primitives into functions. There are things that we're going to get into down the road that we're going to talk about, like when we talk about pointers and stuff like that. But on the onset, using structs in a function is just like you would expect, right? Now, one thing I will tell you is you can pass members. So here, because we have that dot operator, we're passing just that one member, or you can pass an entire struct. Now obviously the function that you're passing to needs to know what you're doing, right? So you're going to develop a method that is expecting either an int, like in this case, I think it was an int, or is actually expecting an entire struct known as student, this type of student, right? So that's where it gets, just like, but that's how we did it with the primitives. You can't just pass a string into a method that was expecting an int. Same thing here. So with this, we've got this code, this struct, and we have this function that's somewhere in the code. And as you can see, it's expecting you to pass in an entire struct of type inventory item. And they're, of course, doing the one thing that drives me nuts. They're using single letter variable. I will tell you, as you start getting into structs and in classes, you'll see it happen more often. I strongly am against this. In fact, it is one of our practices at the place I manage, that we do not use single letter variables. The only place you can use single letter variables is in for loops, where you're using it as a counter. All right. Some notes about structures, and I apologize, I'm just going to read the slide here, which you could definitely have done, but as I'm reading, if there's anything that pops out, I'll make sure to notate it. But using value parameters for structures can slow down a program. It's wasted space. You're going to want to Google this. Find out why. Find out why it's wasted space. And it will make sense, and it'll come up pretty quickly once you do this search, why it's wasted space. Using a reference parameter, and remember the difference between value and reference parameters. If not, make sure you do the research to figure that out again. Using a reference parameter will speed up programs, but function may change data in the structure. Remember that? One of the things about passing by value is you're passing a copy. By the way, that might give away why we're talking about wasted space. But if you pass as a reference, that means you're actually passing an address to the original object. And so that way, if this function changes it, then it changes the original object too. Can be problematic. Using a const reference parameter allows read-only access to reference parameter, does not waste space and nor speed. So again, here is a method to show you the const as part of the incoming parameter. By doing this, will make it run faster and won't allow changes, which again, I believe at some point in this semester, we will start talking about that as well. One of the things you want to do when you're developing is try to make your code bulletproof by not, if an object doesn't need to be changed, don't let it, right? If you know, hey, this function should never change this particular incoming param, then stop it by and guaranteeing that it doesn't by using const. All right. Returning a struct from a function makes sense. This is what we would expect. You're going to have functions that can return the same thing. It can return a structure, and so here we have a structure that is being returned. Remember when we have functions that start with void, that means it returns nothing. But if we put like an int or double out there, or in this case a struct, that means this method is going to return this type. So when we make use of that, that's why we have to have that equal sign, because this method is going to return that struct, that type of struct. I don't even want to spend too much time on this. Take a look at this. This makes sense. You've got a function here that creates a struct right there, and then returns it. As well, now we got to look at a full-blown function and pulling it all together. We've got this circle function, excuse me, circle struct, and then we've got this prototype for get info. So that means it's going to be on the next page. And there it is. And with that, you can see that this this function is doing stuff to the struct that it's that was returned. So this get info returns a struct, and then we are then doing things that change that struct. Finally, this is that get info function. This is the one we were saying that's going to return. So it's going to create a temporary structure. It's going to do some changes to that structure, update some of the member variables, and then here we go. It's going to return it back up, the function that it created. All right, on the next video, we're going to get into something a little bit more complicated. This is pointers to structs, and we are going to then learn how to make use of pointers with structures. So with that video, we're going to probably take a little bit more time to understand it. So when you come on back, make sure you bring some coffee. All right, thanks.